Welcome to the Royal Society of Arts, the RSA, in London, a venue with a great heritage of people that have made a difference. Authors, writers, industrialists, people that have really contributed to not just life in the UK, but all over the world. So it's a perfect venue to bring together equally a wonderful audience today of people that are trying to do those things, make a difference in and around the world of electric vehicles, battery, energy management, the whole gigafactory revolution that's going on.
The issue at the moment is this energy transition has to move faster than historical ones. If you think about the slow speed of moving from coal to oil, coal was actually first half of the 20th century, coal was still dominant before oil. So it takes a long time to make these transitions, but now we don't have that time.
People fundamentally underestimate how many facilities need to be built to satisfy the energy transition.
You talk to sectors, so you can only have a conversation about the automotive sector or the aerospace sector or the static storage sector. Nobody is thinking about the demand for batteries overall, and that's a significant problem.
In the end, what happened in China is, of course, replacing ICE with electric cars. But is that really the solution to sustainability, what we are seeing so far? I don't think so.
Do we need to think differently now with logistics? In your world and your experience, what have we now got to start doing?
Well, number one, we have to become problem solvers.
The fraction of end-of-life batteries, for example, electric vehicles, is still a small part of what we see as a recycling feed. In order to produce the batteries, Tom will know that very well, you have a certain scrap rate, and that is today 80 to 90% of the recycling feed comes from these cell production plants.
Wow. So the way how logistics can help is to work together in a vertical supply chain, to talk to port operators, to talk to carriers, in order to provide capacity, first of all, to provide a channel to transport these batteries in an effective and then an efficient manner.
Coming back to the battery topic, when you need to build a car that's 3.2 tons in a factory, well, lots of the factories in Europe don't have the hangars and conveyors that can do it, right? So you need to spend $1 billion to convert that factory, to put in the infrastructure just to move that material.
So let's just go briefly around and say who they are. So starting over here on my right, we have Henry Sanderson. Henry has a wealth of experience in understanding the global mineral business, the challenge of where are the essential minerals that sit within the whole journey of new energy and new mobility. Recently authored Volt Rush, which was a chronology of how have we got to this point, where does the stuff come from, what happens next. If I can give it that kind of summary, I hope that's okay, Henry?
Yeah, that's perfect.
Good, thank you. Next to Henry, we have Einar Jensen. Tom is now busy building the Freyr Gigafactory proposition up at Mo i Rana in Norway, northern Norway, and I'm sure ambition for many other things to come. So Norway is so busy with so much of this, Tom, so great to have you here. You're more than welcome.
Great to be here, Roger.
And then an individual that I've known, and as I've said to Andy Palmer in the past, very much has given me inspiration on my electrification journey, given the work that Andy did way back with Nissan, with championing the Nissan Leaf, the V2H, and many other things. So Andy, great to be in your company again. Nice to see you. Daniel Kirchert from BMW originally in terms of the electrification journey, as I recall. And then in China with many, many things. Co-founder of Byton, that amazing ambition. Okay, didn't quite get over the line, but was well on the way, and many other things. So Daniel, you're more than welcome. Julia Pongraz. Julia understands transport and storage of new batteries better than most in the world, I imagine. We're certainly going to put you to the test on that, but you're welcome, Julia. And then Elewout Depicker is from LiCycle, one area that perhaps doesn't get a great deal of focus at the moment, but increasingly, without doubt, will do, which is recycling. So LiCycle at the forefront of that. Achim Glass is really the leader, the thought leader in many ways within the biggest logistics company in the world, Kuehne and Nagel, and we've worked together on a few things before, so that has given us inspiration to see what we can do together again, hence we're all here, which is wonderful. Then Christopher Ludwig, who really understands, if you like, that end-to-end side of things, the supply chain aspect of things. We've never met before, but we're going to find out a lot about each other, and we're fellow Bob Dylan fans, so that's definitely what we've got in common. So, by way of this discussion, we're going to go through 8 areas. That's why we've got 8 speakers, and we're going to try and give you a flavour of how does it all join up? What happens next? I use the word hope. Hope is the significant thing I believe that we will see out from our conversation today, ladies and gentlemen. And so, if I can start with you, Henry, can you give us a flavour of some basics, if you like, 101, if you like. What are the, say, 5 essential minerals that we're now harvesting from the world? We're digging them up. And where, from what you learnt in writing Volt Rush, is the kind of state of the art at the moment, the state of play? Can you give us a flavour of that, please?
Yes, thanks very much, Roger. So to make this energy transition, as you all know, we need to electrify transport, electric vehicles, trucks, etc. We also need energy storage to help integrate wind and solar, and all this requires batteries on a scale I think few people appreciate, and a scale at which we certainly haven't been used to manufacturing. And in all of these batteries, at the beginning of their lives, they depend on raw materials dug from the earth, and the minerals in most batteries in your electric car are lithium, nickel, cobalt, graphite, manganese, and they all have quite interesting and complicated supply chains. And the issue at the moment is this energy transition has to move faster than historical ones. If you think about the slow speed of moving from coal to oil, coal was actually first half of the 20th century, coal was still dominant before oil. So it takes a long time to make these transitions, but now we don't have that time. We have to meet the net zero targets to stabilize temperatures, bring them down to 1.5 or 2 degrees. And that means we really need to accelerate manufacturing of clean energy technologies. The issue is that building a mine is not a simple, quick, or easy process. In fact, it's a lot more difficult than building battery cells or battery materials. So the issue you have is we have to get to grips with how to mine more of these raw materials in a very tight time frame to meet the sort of exponential part of this demand that we're going to see this decade. And the issue is that for the last 10 years, the West has let China do a lot of the financing, not only on the mining side, but also the processing of these minerals. And China today processes almost all these minerals. And despite knowing for years about EVs and Tesla, Europe has failed to build any lithium mines or lithium refineries, and not that many battery cell plants. So despite having the visibility of what we need, we haven't done it.
Yeah. And what can I ask you, why do you think that is? Why has China stolen a march on the rest of the world? Why?
Well, so what the reason is this is globalization, and we've been very happy to offshore a lot of industries to China. Happy is probably not the right word. The West has encouraged it, and Western elites have profited from it. They've lobbied their politicians to support it for decades. So we've been very happy to offshore that. And when the lithium-ion battery came along, it started in Japan, consumer electronics, and then it moved to China. And at that point, China was at the lower end of the global supply chain, and it could undercut Japan by cheap labor, by having low environmental standards. And the West was just so happy and too happy to outsource a lot of those businesses. And then China moved up the value chain when electric vehicles came along. And those very same companies, if you think of BYD or CATL, they started out making batteries for consumer electronics and undercutting Japanese and then Koreans. And so then China could move up the value chain and scale production very quickly of these battery factories. And the dirty sectors of refining lithium and things like that, to refine lithium, you need to heat rock from Australia to 1,000 degrees, often using coal-fired power or natural gas. It's not an industry that the West has given much attention to.
Now, do you know what? Out the corner of my eye, I can see Andy Palmer nodding on this, because Andy had a box seat in Japan of everything you just described. And so, you know, the why has that happened? Thank you. That's given us a nice flavour. I think that's a good intro to it. And I definitely recommend to anybody read Volt Rush, because I learned a lot in it about certainly when you get into South America, the lithium triangle, when you look at some of those key companies like SQM and Albemarle, etc., understanding where have they come from, how did they get here, how quickly do they accelerate. So certainly we're going to come on to some of those references you put in there. So Henry, thanks. That's a really good insight into not just your book, but just the chronology of why these things are happening. The here and now then, Tom. So you are busy putting together a gigafactory in Mo i Rana. I'd love to come there sometime, because it's right in the north of Norway, just below the Arctic Circle, as I understand. And I know why you're there. I think I know why you're there. Access to cheap renewable energy, hydro energy. But what are the challenges in putting together a battery factory now? And given what Henry was talking about, how quickly can you do that? And are you doing anything different that you would like to share with us, specifically in regard to Freyr?
Sure, Roger. So first of all, thank you for inviting me, and it's an honor to be here with all of you, speaking about things that we are, I guess, above average interested in, biased as we are in the whole electrification journey. So let me just take a step back and sort of build upon what was said earlier. So of course, lithium-ion batteries were introduced in 1991 by Sony Murata for consumer electronics. And we scaled the hell out of that, pardon my French, because basically people wanted a lot of handheld devices. Yeah. So prices for lithium-ion batteries came down quite dramatically. And since the price of lithium-ion batteries came down dramatically, the use case for lithium-ion batteries started to sort of expand into electric vehicles and ultimately also into energy storage. But we have to bear in mind that the way in which these batteries predominantly still are produced globally today was not intended for the use it's now predominantly going into. So the form factor, the way in which it's produced, how it's produced, and how the energy is contained in these small cylinders or prismatic boxes or whatever have you, is not ideal for the purpose of what it's being built for. Now, so what we then did in Freyr, a Norwegian company, was to sort of think about is it realistic to assume that we can compete in this industry? Because this is an Asian dominant industry today, invented by the Japanese and then taken over to a large extent by the Chinese and Koreans, but still producing roughly the same batteries as we were doing 30 years ago. And we asked ourselves the question, will we be able to succeed if we try to copy what the Chinese are doing? I mean, everyone starts thinking about the Chinese copying what the West is doing. Is there any merit in thinking that you can succeed copying what the Chinese are doing? So we rapidly sort of recognized that that's not something that we can succeed in, because we just don't have that, let's call it mental model or business model at heart. So we started with not necessarily looking at Norway's comparative advantages, which is large availability of low-cost renewable electricity. Of course, producing batteries is energy intensive. Producing the materials or processing the minerals and rocks that were talked about into active materials for battery production is also very energy intensive. So of course you have this intrinsic advantage of low-cost renewable energy in a world that wants to decarbonize. So if you want a world that is decarbonized, removing the tailpipe is one obvious thing, because you just put batteries in a vehicle. But you then need to charge all of these batteries also with renewable energy, which requires a lot of storage to ensure that you can have sun and wind into it. So we looked at Norway's industrial heritage, which is really renewable energy projects and renewable energy exports and large project execution experience and painstaking, let's call it, focus on quality and safety in extremely harsh environments operating multi-billion-dollar projects. Because what really the world needs is to scale this up by a significant factor. I could not agree more that people fundamentally underestimate how many facilities need to be built to satisfy the energy transition. And that is what we saw Norway could be a part of solving. So Mo i Rana has the lowest, we probably have one of the lowest cost electricity PPAs in the battery industry. But when you're
in the world.
In the world. But when you're into it, you actually want to minimize the use of energy in anything industrial you do. And that's what we're trying to do. So then we looked at what technology do we apply? Do we do traditional cylindrical 21700 batteries that is kind of mainstream in high energy density sort of vehicles today? Do we sort of find a new clever way of producing prismatic batteries or pouch batteries? And what we really decided was that we needed to find a technology solution that could offer step change in performance and cost, and then take that to industrial scale, and that's what we're doing in Mo i Rana.
Right, right. Quick question, if I may, on all of that. Yes, you're in a great location for access to cheap renewable energy, potentially in the world, which is extraordinary. But what about the practicality of getting those raw materials in there? Isn't that then a difficult location? You know, goods in, goods out, the whole logistical side of, you know, how does the lithium arrive? Is it in bags? You know, is it in pallets? I mean, what are the practicalities in all of that stuff coming in, and then all of those batteries coming out the other end, given where you're located? You're not adjacent to a port, you know, you're not adjacent to, and many of the gigafactories aren't. So how does that get reconciled?
Well, so actually we are adjacent to a deep water port.
Oh, okay.
And so there is excellence. So when you do site selection, you have a broad variety of criteria you evaluate different sites against.
Right.
One of them is obviously logistics. So in Mo i Rana, we have an excellent deep sea port and expansion plans to sort of further improve the characteristics of that. There is rail access, there is air access, there is road access.
Right.
And, you know, climatically, it's a nice location. And of course, energy prices and availability with 5-6 terawatt hours of surplus energy in the area of, you know, ultra low cost hydropower obviously gives it a certain additional ring to it. So Giga Arctic, which it's called, will be opening up in 2024. We're building the first production line, a true replica of the 8 production lines we will have in that in our, let's call it pilot plant, but it's really a customer qualification plant. And it's actually doing exactly what the name indicates. We're qualifying our batteries for our customers, and we're doing it in an actual industrial scale so that you can replicate and train your operators in this improved process technology for producing larger and thicker batteries, more designed for the end use cases that it's going into, and then just replicating those, let's call it industrial machines, many, many times. Then you have a modularized footprint. And when you have that modularized footprint and the engineering for that and the training for that, you can copy, paste, or replicate that in many, many locations around the world.
Right, right. Well, thank you for all of that, Tom. And I think what's particularly significant in what you're doing and what you've said is the fact that you're not just copying China and the Chinese process, including being far more forensically focused on reducing that carbon footprint of both the energy to make the batteries, but also the industrial process in and around the processing of those minerals. So this isn't just a shift to build battery capacity in Europe and America. It's to do it much better, without being, rude to the Chinese or anyone else. Andy, 15 years ago now, I guess it would have been about then, there you are at Nissan with the vision and belief to progress the Nissan Leaf. You are absolutely the right man in the room, as far as I'm concerned, to really share that journey with us around how did you go about finding battery factories? I mean, there weren't so many, not of the size that we're talking about now. And like I said earlier, you were nodding profusely when Henry was talking about the chronology of all of this, from consumer electronics and batteries, then into electric vehicles. Where's your sense of hope, if you like, for the world in general? And then if I can home in on Europe in particular, and maybe say a little bit about the UK specifically. But where are you now, having so much knowledge and experience in this?
There's a lot of questions packed in there.
Yeah, sorry. Yeah.
Look, back in 2007, 2008, there wasn't so many choices as far as batteries were concerned. There was obviously the consumer electronics industry, but there wasn't any kind of EV industry, and certainly not an EV industry that we thought was appropriate. So I was responsible for putting together the joint venture which became AESC, which was a joint venture with NEC, which was obviously the source of the particular sources of some of the technology that went into the batteries. Nissan was really about the industrialization of the batteries, and eventually AESC, actually through the dark days of 2008, with help from various governments, was able to put battery factories in the US, in the UK, and in Japan. At that time, I think it's true today, it was all about safety. You've seen what happens when you get runaway incidences with batteries, and Nissan was fundamentally concentrating on two major points, the supply chain being one, and safety being the other, which is why, I mean, the battery on the Nissan Leaf was 24 kilowatt hours, which I actually think is a perfect size for a battery when you've got a proper infrastructure. But we also used a chemistry called LMO, which was not as good as NMC, but
is that lithium manganese oxide?
Yeah, exactly. But you know, eventually you move to NMC, so you see the Japanese approach, if you will, of incremental improvement, putting safety first. And I think I'm right in saying that the Nissan Leaf has never had a runaway fire, which is somewhere a testament to that approach. So that's how AESC got formed, and eventually, of course, AESC was sold off and became owned by a Chinese company, and there you start to see the rise and dominance of the Chinese. Again, I was also a director of Dongfang for many years in China, and you saw the central government thought on electric vehicles being the leapfrog technology to dominate the car industry over a long period of time. And if only some of our Western governments could have a thought process that didn't go beyond their next election, then we might not be standing on the precipice that we're standing on to some extent in Europe, but certainly in the UK, which is basically we don't have enough gigafactories. We don't even recognise the demand that's really here. I mean, I talk to politicians in the United Kingdom, for example, because the battery company that I chair, which is Innobat, is considering where in Western Europe it should put its battery factory. And you talk to sectors, so you can only have a conversation about the automotive sector or the aerospace sector or the static storage sector. Nobody is thinking about the demand for batteries overall, and that's that's a significant problem.
It is, and I mean, Tom alluded to that, and I think it is important to re-reference that. We're not just talking about electric vehicles here. We are talking about many other things, and specifically the ambition of the renewable energy industry to be able to store that intermittent energy. So whether it's in the chemistry selection, whether it's in the cell format, whatever it is, having the ability to do kind of all of that stuff. I'd just shout out Nissan because, of course, Tesla is the kind of big poster boy of the EV story. Certainly in the West, in China, arguably, maybe Daniel, you'll give us a flavour in a moment. It's BYD, you know, in China, but Nissan were very much there already with the vision of having bidirectional charging, having batteries from EVs become stationary storage. And I know one of the big facilities, sports facilities in Europe, uses a ton of Nissan Leaf batteries to, you know, store up their renewable energy. And run that. I think it's the Johan Cruyff facility, if I remember rightly. So final question then, Andy. I'll try to make it one question then. Sure. So given you've given us those dates and where we were then and what happened with Japan and then China, and can you point a particular moment in time where we just started getting it badly wrong in both Europe and America in not watching what was happening?
So I think Japan, Nissan, Mitsubishi, China, new energy vehicles with a progressive strategy through plug-in to electric vehicles was moving quite quickly, and the West wasn't looking. The West hadn't taken climate change seriously. The West was fully invested in internal combustion engines, and electric vehicles was taken as a distraction. And it was, to some extent, I suppose, a disbelief in the science of climate change, but it was also an arrogance of continuing to support a profitable industry.
Yes.
If you were to look at it and look the board of Nissan, when it didn't follow through on Leaf and EMV, looked through Western lenses and looked at the cost of producing an electric car at the time, and the cost of goods sold was higher than the MSRP. So it wasn't a profitable business. But companies like, let's say, BYD and even to some extent Toyota are able to look through into the long term. And I think that's the difference between having a long-term economic strategy like China that said 15 years from now we want leadership in vehicle manufacturing, and the way to do that is with electric cars, and the West's obsession with quarterly results and protecting its current industry. And I think that's where you got the disconnect. Now you can take as a focus of that the United Kingdom, which is very, very focused on short-term returns, and has essentially moved from number 2 car producer in the 1950s worldwide to, I think this year the UK will probably end up being 20th. So this massive decline and lack of ability to invest in its own car business, which supports 800,000 people today. That's if you don't take care of what's important, then you lose it.
Wow. Yeah, that's saying it like it is, Andy, which is why you were invited, and you say it with authority because you've lived that. In the same way, Daniel, you have as well, because you've had the box seat, as Andy has had in China, in Japan. You have within China. And as a German, I'm fascinated now by what Andy was talking about, the relative position or relegation that the UK is in our auto industry. How does the German auto industry now see it? You know, you've worked hugely in China for many, many years. What's your set? Do you agree with Andy?
Yeah, absolutely. I very much agree with Andy and also with the other previous speakers. So it's very interesting, as I was able to witness this in China, where that came from, that China made that plan. It came, basically the Chinese automotive industry started in the 80s, and then there were all these joint ventures. But the government came to the conclusion in the late 2000s that the own industry is a failure. On the gasoline side, I mean, they were still 30 years later not starting to go global, only local, very low end, low price, not like the Koreans and Japanese. Yeah? So out of that, they started to say we go into NEV. Yeah? We leapfrog this. This is a chance for us to become a global player. And of course, there was also the environmental consideration and geopolitical consideration of not being oil import reliant to do that. But most important, it was a kind of chance to leapfrog. And that drove along the batteries story, right? So, and the battery, by the way, CATL, the first foreign partner which used their battery was BMW and Shenyang when they used it in a local brand vehicle called Zinoro. And after that, CATL took a fantastic story started for them. Yeah? So it's very interesting to look at this. And I agree also, unfortunately, in Europe, there is too much legacy and too much success in the past in the ICE, which basically was complacency and also not too short-term view. Yeah? But on the other side, if I look at what Tom is doing with Freyr, this gives me a lot of hope that Europe has a chance not just to copy and play the catch-up game, but to do it in a different way, which is more meaningful. Because in the end, yeah, what happened in China is, of course, replacing ICE with electric cars. But is that really the solution to sustainability, what we are seeing so far? I don't think so, right? If you look around, it's great to see. In China now we have 15 to 20% penetration of EVs, in Europe around 10%. But most of these cars are very expensive cars, and are cars which weigh 2.5 to 3 tons. So that can't be the solution to sustainable mobility. In the same way, like what Tom is doing with Freyr is trying to build the most sustainable battery, a truly sustainable battery. I think some players need to think about how we can make a truly sustainable car, using less resources, using not 2.5-ton car or an air vehicle, and also making it affordable. We're not gonna solve the global energy transition by just targeting the premium segment of the market with 15%. So we need to really have something affordable to everyone, right? And there's nothing happening in this area. So I think it's very important to also look at this. And this is, by the way, what I'm now, after being back to Europe after a long period in China, I'm working on in the airspace together with Fly Now, which is a very exciting startup, and we are trying to make really affordable air transport, of course, electric air transport, both for cargo and passenger. So this is not
eVTOL, isn't it? Electric vehicle.
That's right. It's an eVTOL. So, but basically, this is not about just making something which is gasoline and only available for rich people, making it electric, but something which is more affordable for everyone, and helps us to bring this transition forward.
Quick question for you again, Andy. Do we miss a trick in not electrifying buses, taxis, vans and trucks before all of these luxury cars that Daniel's talking about? Could we still do that again and sort of think, okay, look, let's go back to basics here. What are the two imperatives here? They're tackling climate change, improving air quality. If all of the buses, taxis and vans out here in London and all the other cities and major conurbations were electric, would we not radically change that air quality thing? So shouldn't it be, because you've got a background in buses as well, and I mean, your vision then, let's be frank here, you're German, please don't get upset when I say this, but Volkswagen is supposed to be the people's car, isn't it?
That's
so
right.
if you want a Volkswagen of electric vehicles, it can't be a 50, 60, 70, 80,000 pound, euro car. It's got to be a 15, 20, 25,000 pound car, hasn't it?
So I completely agree with Daniel. Obviously, I think you've got to get to the democratization of net zero. You've got to allow people to travel with a zero carbon footprint. We sometimes forget about air quality. 50% of the particulates outside this window in London is generated by buses, taxis, and vans. There are, for example, in the United Kingdom, there are 40,000 buses in the country. There is no better application in the EV space than a bus, because you have a fixed mission every day. You know exactly how far you've got to do, and you know what the charge rates are. And it's actually cheaper to run an electric bus than it is a diesel bus. So all the barriers are down. So the obvious thing is, of course, it's to move buses, taxis, vans as quickly as you can, because you get the biggest bang for the buck. After that, then you have to talk about personal transportation, cars. And I think that we've headed in the wrong direction when you talk about the democratization. We started, let's say, we say that Leaf was the creator of the modern day electric car. It started with a 24 kilowatt hour battery. What's happened is so-called range anxiety. So the car manufacturers have concentrated on growing the batteries. So you now buy a Tesla with over 100 kilowatt hours, carrying all of that redundant weight and cost, when the average journey is, I think it's 8.4 miles. So you carry all of this in reserve power. I think what we have to do as humanity is concentrate on a prolific charging infrastructure, and we need to get the battery size back towards that 24 kilowatt hour. Because when you do that, when you think about ultimately what the cost per kilowatt hour of the battery makers are, times by the size of the battery, times by light weighting of vehicles, then something like a $15,000 car is absolutely achievable. And you need to get there if you want to get to this democracy of zero carbon.
Yeah, absolutely.
You're completely with Andy on this. But can I ask a technical question? So when you talk about eVTOL, I guess aerospace, anything up in the air, is the most challenging thing in terms of standards, legislation, all the other stuff. What chemistry or what sort of batteries or all that sort of stuff? I mean, where are you with that then?
Yeah, so of course it's always important, especially for air transport, to have good energy density. On the other side, you want to use mature technology and safe technology, and you have to deal with redundancy. So currently with Fly Now, we plan to go into serious production in 2024, and we're using the 21700 battery cells. So but with a very innovative way, with an Austrian company helping us to build the battery pack. And we can achieve more than 200 watt hours of energy density there on a system level. Yeah? So this is good enough. But I would say it's not all about energy density of the battery, right? It's also about smart engineering of the vehicle itself. For example, this vehicle we are working on, it has an empty weight of 240 kilogram. So it's a super light architecture, right? And this is key. And by the way, so if you go to the car, I think it's the same thing, right? A lot of OEMs, they were just sitting there and waiting for battery prices to come down or for energy density magically go up. I mean, both has happened to a certain degree, but not enough, right? But they have completely neglected to improve the architecture of the car, to lose less resources, to make it more smart, more lightweight. Because if you use half of the weight for the car, you need only half a battery to get the same range. Yeah? So that's a direction we need to go for the future. Yeah. It's impossible to build cars with 600 kilogram of batteries, 2.5 tons. This is not going to solve the issue.
This is Henry.
You know, just to say, it is interesting about mini EVs, because in China the best-selling electric is a little Wuling mini car, and if you think about what China's done, you know, they've made the high-speed rail so good that so for longer journeys, you know, when I lived there, we always used to fly Beijing to Shanghai. You would take the train now, so you might have longer journeys, high-speed train, and then use smaller EVs for getting around your city. And this, I think, is you know, important to use the energy transition to rethink mobility in a broader way, so that we can just have small EVs and we don't need to have carry around huge batteries.
Yeah, just want to sort of add one perspective to this. So I 100% agree that, you know, reducing the weight of the car and integrating better battery solutions into a redesigned architecture of the vehicle is obviously something that is going to happen. It's inevitable, because it doesn't make sense to use combustion engine-based engineering for electric vehicle mobility. But we should also think about the clear linkage between electric mobility and energy storage. Because if you think about it, if you have 100 million vehicles sold a year and you have close to 2 billion vehicles on the roads around the planet, in some distant future, we have replaced all of this, or a fraction of this, with, you know, moving storage devices. And you start thinking about electric vehicles not only as a means of transportation, but also as a democratization of energy storage. Because you have these literally mini ESS facilities that are moving around on wheels, and with bidirectional cables, you will get a completely different way of thinking about optimizing the energy system globally.
Absolutely, and I mean, without doubt, this was a part of the vision of Nissan. I mean, as a company, it doesn't often get the credit it deserves, actually, for a lot of that, you know, forward thinking and innovation.
No, you're right. Actually, the idea of being able to charge your home from your leaf was a direct consequence of the earthquake and tsunami, where it knocked out, as you know, all of the energy in Japan, and we saw people dying on life support in hospitals. And yet we had technology in the labs that could do that, and we were able to bring it to market very, very quickly. My home in Tokyo had a leaf to home, which was amazing. Look, this is 2011, 2012. Humanity's not moved quickly enough.
Yeah, but that's a great illustration, Andy, of necessity as the mother of invention. And if there's not a necessity at the moment to invent a bunch of stuff, that's what it is. So, Julia, can I come to you? Because we've talked here a lot about you make batteries in China. There's CATL making a third of the world's cells. There's all of this movement of both raw materials to go and be processed, then put in batteries, then the batteries shipped across half of the world or most of the world. Your expertise and knowledge now in this logistical challenge is, as we're trying to reshore a lot of activity post-COVID, post the war in Russia, post all these different things, how is it all coming together? I mean, where the heck are we? Because it's, you know, do we just carry on doing the same thing? Tom's point about not being the same as China, think differently. You know, that's an Apple mantra, isn't it? You know, do we need to think differently now with logistics? You know, in your world and your experience, what have we now got to start doing? What can you share with us about all of that?
Well, number one, we have to become problem solvers. So in logistics, what's exciting is hearing everyone, we're all trying to solve a problem, and one that makes us feel like we're doing something in our day. In logistics, usually you're just moving freight, so shipping from point A to B. And when you visit customers, the worst conversation is when they just say, I just want it off my dock. And they don't think about it past that point. But now the conversation shifted, and it's exciting to be in logistics and supply chain because all of these things we have to study and learn. I have to learn, I have to read more, I have to research more. And the key areas around the batteries and electrification, besides all the disasters and geopolitical things that keep hitting us, that cause challenges, is the legislation. So if you really follow the legislation in each country, specific to North America, you see a fundamental shift. So now today, it's not about what are my shipping lanes? I want things moved at an effective cost. Now cost isn't even a conversation because it's what are the requirements to ship, and they've changed just yesterday. So what is okay yesterday to ship from China, tomorrow is banned because of safety, because of issues that happen, and then we have to pivot and adapt. So I've been coining this term, talking to a lot of customers through with, you know, automotive logistics, which is we have to be proactively reactive, because being reactive is not good, and we can't be proactive and anticipate whatever happens. So within the legislation, the things that we talk with our customers about is you have a limited quantity to move. It's dangerous goods class 9. They don't really need to understand what that means, but we do. And then we need to understand what mode that means it can ship on. Not every carrier wants, this isn't ideal cargo for them, over shipping consumer goods. And then at the end of the day, you have to be very prepared and coordinate with your shippers, with your end customers. And then you have to say, can it be moved and when do I need it? Which is everyone's just in time in automotive. Maybe just in time isn't necessarily ideal in some of these situations. So what we really find is we need to really coordinate and look at, we've been coining the legislative jungle term Achim and I have been talking about. And it's almost like I have to now become a lawyer mentality to read and digest these words. And our brokerage and our customs become important because that's really the touch point. It's not so much the transportation, it's the touch point from the document shipping all the way through in the supply chain.
Yeah. Now, you say it's not so much the transportation, but given some of what we've heard and this ambition and journey we're on of possibly having 300 plus gigafactories kicking out every year 7 terawatts of energy storage, how can we scale all this up? You know, is there enough shipping? Is the shipping as low carbon as it can be, or can that improve? Because we don't just want to rebalance, if you like, the kind of geopolitical management and development of batteries. We need to reduce the carbon footprint of them. The point we're saying about lightweighting, the point we're saying about smaller vehicles, the point we're saying about commercial vehicles and public transport, all of that feeds into it. But at the moment, we're not making 7 terawatts of energy. So when we do, is the logistics chain going to work, or will it just collapse under the sheer weight of it all?
Yeah, I think at one point in time we didn't have roads to drive our cars on in North America, right? So someone had to create roads or railroads, and I think the same thing needs to happen with our ocean carriers and our air carriers and the road as well, to say, where am I going to charge my vehicle? What steamship line is going to want to use new types of fuel? And share that and have a commitment. And that's what we try to do, is talk with our customers and have them explain that part and make sustainability a conversation before it's just about the output of the vehicle. It has to be included. And we're seeing more and more conversations around that. But I don't think we're ready. But I think we need to get ready and understand all of the things we're talking about today to pre-plan. That's the part we don't see. It kind of hits us as an avalanche. And then we're trying to backfill the conversation with our customers and the carriers.
Tom, are you going to say something?
Yeah, so, I mean, at the end of the day, what we're really trying to solve for is how do we transport, in a way, renewable energy to the end customer in the most efficient way possible. And I think supply chains and logistics have a much bigger role to play in that than what we're considering it today. It's kind of thought about as, I produce a battery, I put it in a module and a pack, and I put it on a container on that ship, and it's transported from A to B. But why don't we think differently? Why don't we make the transportation journey part of maturing the battery? I mean, there is nothing intrinsically that, hinders us in the energy storage world, for instance, to consider formation and aging a big part of the cost structure in producing batteries, doing that inside containers on a ship, right? I'm not saying that that's something we can do tomorrow, but that's the way we need to start thinking about it. How can we utilize the infrastructure that we're building for the purpose of reducing the complete cost structure across the entire value chain?
Yeah, and in a similar regard to that, Henry, when you were researching and then writing the book and visiting all these places, did you get in a sense of there's an unintended consequence of trying to do the right thing, electric vehicles, renewable energy, but the consequence of that in digging up all the minerals, moving it all around, was, a kind of dirty secret, so to speak. Well, it's not so secret anymore, is it? Did you get, what was your sense at the end of writing that book, that we're doing the right thing, or as we're alluding to, we can think differently and do some things better? What was your kind of mindset at the end of that whole book?
Yeah, I mean, I think, all the studies do show that EVs obviously are better. I mean, we mentioned air pollution, and what we're trying to do now is trying to reduce the carbon in the supply chain. You're right, so that we don't have the unintended consequence of your scaling up. And once you scale up, you're actually producing a lot of carbon in the supply chain. And one of the sort of issues is Indonesia, where you're digging up nickel in the rock. About 1% of the rock is nickel, so huge amounts of waste produced just from the mining, and then you're processing this nickel in Indonesia using coal-fired power, and then you're shipping this nickel to China, where it's further processed using coal-fired power, and then made into battery using coal-fired power. So I don't think many people understand all the sort of carbon emissions involved in China, and then perhaps charging your car with coal-fired power. So this is why everything in the energy transition needs to move together, and it's also renewables are the key for unlocking so many things, right? Because renewable penetration increases, you can charge your car with cleaner energy. Countries like Indonesia do have net zero targets. Once they increase renewables, then they can make the supply chain greener. So that's why that's why everything working together is so key, and why renewables unlocks so many different potentials.
And then pivoting back to the legislation now is trying to drive some of that processing so it doesn't do that. So you see, like in the United States, there's an appetite, and in Canada to offer incentives or offer goals so we can move some of that processing to be done. Not all of it is not ideal, but some of it to be done locally, which 3-4 years ago, I wouldn't have guessed that would be there, right? And it's not just about wanting to have the consumer buy the electric vehicle. It's about it's this regionalization, because nearshoring's kind of an overused term, but we call it a localization or a regionalization of what can be done. And we see a lot of that conversation now happening.
Yes, so just quickly, that's the advantage of localization, is you can do it in a greener way. That's the hope. You obviously don't have to copy the same process.
Yeah, I think there's an unintended consequence of whenever you bring new technology, there's always an unintended consequence. Yeah. Gasoline to diesel, diesel particulates, diesel to electric, the high carbon intensity in the manufacturing. I think you've got to raise awareness of it. And I've been pushing the UK government recently to consider something like a Monroe label on every car, rather than fuel consumption, but expressing carbon footprint in the manufacturer. And we know, for example, some excellent work done by Polestar and Volvo, which shows that an electric car takes about 70% more CO2 than a normal internal combustion engine. Obviously, over life, it's still better. Yeah. But I think there's an education process to go there. And I think we're all advocates of EVs, right? With the advocation, that doesn't mean that you have to recognize the downside and address the downside. I'm sure that the mining side of batteries will somewhere get partially solved by the recycling of batteries, for example.
We're going to come on to that in a moment.
The geopolitical issues around some of the minerals maybe get solved by engineering of different chemistries, but there will always be, whichever step you go on, there will always be an unintended consequence that means you need to continue to innovate.
Yeah. Do you know what? I have a favourite analogy at the moment, which is all of what you're talking about and all of what this is like a Rubik's Cube. It's like trying to get all the facets to come round to the right colour, as you click around a Rubik's Cube. And if you don't know what the algorithm is to actually get it made, you'll never do it because it's so complex, so many permutations. So I think as an analogy for the journey that humanity is on, it's like a Rubik's Cube. We're trying to click all the facets, geopolitics, energy, cost, the whole load of things, all clicking around each other. But thanks for that valuable segue into recycling, because, that's why Elewout is here from LiCycle. So relatively new company, but been around a few years now. Given, again, what a lot was in the Volt Rush book was, we have to have recycling because we haven't got, otherwise we'll just keep digging it all up. But how practical is recycling when it comes down to logistics? Are we engineering in the capability to extract batteries and mineral materials, take the basic battery out itself? What's your sense of where we are right now? And can I ask a kind of, the question what I hear a lot of people say to me is, why are we talking about recycling when batteries are going to last 10 years in EVs? These companies, surely they're going to be twiddling their thumbs for a decade. Can you give us a little flavour of where that is then at the moment?
Absolutely. And we're here at the Royal Society of Arts in London, and they talked about regenerating the world. And that resonates a lot with what we want to do at LiCycle, decarbonizing the supply chain, localizing the supply chain. And to come back to your Rubik's Cube analogy, by doing that, you make a lot of the parts having the same color. Yeah. It answers a lot of these questions. Today, the fraction of end-of-life batteries, for example, electric vehicles, is still a small part of what you see as a recycling feed. In order to produce the batteries, Tom will know that very well, you have a certain scrap rate, and that is today 80 to 90% of the recycling feed comes from these cell production plants. Wow. Yeah, and over time, by, for example, the end of the decade, that should shift to about 50% of end of life, 50% cell production scrap. So we obviously hope this cell production yield loss will be as low as possible. That would be today the biggest part of the feed. And by building out a network of, we call it spoke, pre-treatment facilities feeding into then one central hydrometallurgical plant closing the loop, you actually have a localized supply chain with a lower carbon footprint, with shorter lead times, and addressing to all of these concerns that have been voiced here.
Now, on the one hand, you think of a gigafactory with raw materials going in, batteries getting made, batteries coming out. So in a recycling facility, you've got batteries going in of all sorts, as you just described, all sorts of batteries. But what comes out the other end then? I mean, in practical terms, is it back to kind of where you were with the raw materials? You get bags of lithium that come out that then go to Tom's place and all the other Innobat and all these other facilities. How's that actually going to work, or is it working now?
Yeah, well, exactly. So you have two types of recycling processes in the world today. You have either the pyrometallurgical route or the hydrometallurgical route. So you indeed have manufacturing scrap or end-of-life batteries coming in, and the first step would be a size reduction step. That could be either through a thermal treatment, so you're burning off the plastics, lithium, graphite, binder, and so on.
And what energy are you using to burn it off? I hope you're using renewable energy to do that.
Yeah, renewable energy, or the process is exothermic, because there's a lot of, like for example, the plastics and so on, that would fuel that process. But having a high recycling efficiency is harder than, for example, with a full hydrometallurgical flow sheet. What LiCycle, for example, is doing is a mechanical size reduction, a shredding process. It's a submerged shredding, allowing us to shred fully charged battery packs. So if you think about these trends, cell to pack, cell to chassis, structural packs, we're already ready to recycle these packs coming in down the line, or when they're not passing the quality control gate. So in the first step of these two steps, so recycling processes, you produce a black mass, which is actually the mix, the shred of all these battery metals. And then the second step, the post-treatment, also called hydrometallurgical refinery, you go back to the fundamental building blocks, your nickel sulfate, cobalt sulfate, lithium carbonate, which we then use to close the loop and feed back into the PCAM or the CAM producers, which are then the suppliers of the cell plants.
Right.
See what I mean about us having to learn so many things.
Yeah. Absolutely. And Tom, I'm intrigued about this. So is this unavoidable? This whatever it was, 10%, 20% scrap that you have. Is that just in the challenge of what you put through those clean and dry rooms, making the anodes and the cathodes? Is that?
Well, you know, electrochemistry is fundamentally quite hard, right? It's all a matter of trade-offs in the end.
Yeah.
But humanity have, an inevitable way of debottlenecking and improving over time. So today, best performing battery facilities around the world are operating at 97-98% yield. And then, so that's one thing. How much actual batteries do you get out of 100% of input? Yeah. And then the other part of the equation is how much runtime do you have in your facility? So that combined is something we called overall equipment efficiency, which tells you how much of the 24 hours a day, 365 days a year, are you actually producing a battery that's saleable. But back to sort of the recycling bit, I think, this is just math in the end, if we think about it. So assume a world that is fully decarbonized. Some say that's a 20 terawatt hour per annum world for 15 years. How much of that in steady state can you assume come from recycled materials? Some say 70%, some say 80%. So let's assume it's 80%. That's a big number. But 20% of 20 terawatt hours is still, huge, right? It's 4 times the current installed battery capacity globally. So if this is true, that means that we technically need to quadruple the current extraction rate of metals and minerals around the world if the 20 terawatt hour game is what we're looking for. Right. But then we're back to what the gentleman has been saying around, well, do we actually need a 100 kilowatt hour car battery, right? Or can we divide that by 4. And so all of these things need to be optimized, but we are inevitably going in that direction. I think scrap rates from production will inevitably be the sort of largest source of recycled materials as the industry is scaling, and it will then at the end of the decade reach kind of equilibrium maybe with recycled batteries. And being Norwegian, we're of course the country with the highest adoption of electric vehicles, so the first large-scale recycling facility in the world has been established in Norway because the availability of end-of-life batteries are starting to become relevant feedstock.
Right. There's a lot in all of that, and I'd like to come back to Andy in a moment about this balance between charging infrastructure or batteries. You know, how do you get most miles delivered? I'm going to come on to that in a second. But picking up on you saying about quadrupling the amount of minerals that we have to mine. So Henry, can I come to you on the fact that Tom's just mentioned we're going to go from, you know, maybe get up to 20 terawatt hours of battery manufacturing a year. That takes a huge amount of minerals. So 7/10 of the planet is covered by water. In your book, I seem to recall the section on harvesting the seabed for nodules of so many minerals where it all sits. Are we going to end up doing that? We're going to have to do that, aren't we?
So I think it will happen. The problem is that it comes down to sort of international regulations, and the international waters, the deep seabed is all governed by the law of the sea. And the International Seabed Authority looks after creating the rules for deep sea mining, and actually they're having a meeting at the moment. So it's quite complicated to get all the countries to agree on what are the rules for mining these nodules, because they're defined as a common resource of humanity. That means that we have to share somehow the revenue from these.
Well, that's a good thing, isn't it?
Yeah, no, it's a good thing. And then countries that are resource rich also have to be compensated for any loss of revenue. So it's a very tricky thing to work out, the regulations, but it will happen. The question is when, and the question is how many minerals are going to be provided from the deep sea. We've got recycling coming that we talked about. Yes, I think it will happen. The question is, what sort of scale, and given the mineral resource requirement we talked about, I don't think it's necessary to say that it may stop some mining on land. We're probably going to need everything, right?
But let's take a choice. Is it going to be better to chop down vast, forestry in Indonesia, or is it going to be, and that's lungs of the earth and all the rest of it, isn't it going to be better not palatable, and it doesn't sound nice, to go and harvest the ocean? Surely it's the lesser of the two evils, isn't it?
Well, I think it's very hard to portray that choice. I don't think you can portray the question in that way. I think it's there is no global authority saying we should do one or the other. That's also the issue. So I think it will happen. It's just a matter of refining these rules. So probably we will get a bit of deep sea mining, and we also will get mining in Indonesia. So
I just wanted to pick in on what Henry said. We will indeed need to rely for a much longer time on primary resources, as by 2030 probably only 5 to 15% of the need for battery metals will come from recycling, and then maybe double of that by 2040. So there will be high growth, but we will indeed need primary mining for much longer. But it is possible down the line, if you think 20, 30 years from now, looking for example at lead acid batteries, which enjoy a recycling rate of over 90%. So you already have the metals here. You don't need to dig them up in any exotic place around the world in lower concentrations. You can just recover the metals locally at an average CO2 reduction of about 3/4.
Okay. Tom?
Yeah, so I think again, sometimes we tend to underestimate the innovative power in humanity. So if you just think about oil and gas, we discovered the huge elephants, as they were called, first. And we built large oil and gas platforms to sort of produce these elephants, as they're called. The large lithium deposits in the world have largely been discovered and are being mined and operated as we speak. But now we're looking for the next generation lithium deposits, right? So we're looking for the shale gas equivalent of lithium, which is now one of the largest producers of gas in the world, or the shale gas or shale oil equivalent, right, in the Permian Basin. Nobody believed that was possible 25 years ago, and now it's the biggest source of oil on the planet. So you will find people looking at thermal energy facilities, right, that are pumping up water from deep, which have high concentrations of lithium in them, for instance, right? That's one example. Brine from the Rhine is another sort of, example that people are sort of extracting lithium from water in the Rhine, right? So humanity is going to get more and more clever in finding the less obvious sources of the metals and minerals that we need. And then the final thing I'd like to say on this one is we are estimating the need of these minerals, which is counter to what I said earlier, based on an assumption that chemistry will be constant, which it won't, right? Everyone is talking about NMC batteries today, but because they're so expensive, the shift to lithium iron phosphate batteries is now happening in more and more applications. And who's to say 10 years from now that we haven't discovered an even better combination of metals and minerals, which then completely, again, redefines what you need for metals and minerals. So we're thinking we need this much nickel because there is 8 parts of nickel in an NMC 811 battery, and if you multiply that by 20,000 terawatt hours times 15 years, it becomes an unsolvable equation. But it's never going to be that equation.
On that theme then, and I like rhyme from the Rhine just because it rhymes, to be honest with you. I can't think of what rhymes with this, but you're in the Nordics then. There's a lot of forestry. Some of the type of forestry can be cut down and planted and grow again quite quickly. What about in the anode having, I think it's Lignode, isn't it, as a replacement for graphite? Is that something you're looking at, or you think the industry might start to look at as another example of going differently, thinking differently?
So there is a company in Norway called Beyonder, which are looking at sawdust as the carbonaceous feedstock into anode materials and even cathode materials. Yeah. So there's, I have no technical insight into whether that is feasible or not. I know the company reasonably well, they're clever chaps. So will we be able to find ways in which to harvest different feedstocks into storing electrochemically energy? Absolutely. There is no question about it. The question is, where is the path of least resistance first? And the second, where is the most bang for your buck?
Yeah. Now, one thing we haven't talked about, and we really, really must, is charging infrastructure, because that's the other side of the coin of battery and battery range, battery size, and all this stuff. And we're seeing around the world, different approaches to charging infrastructure. We're seeing a bit of wireless charging, not much, but we're seeing quite a big growth in battery swapping, particularly in China with NIO, Geely, others, and some interesting partners in all of that. But you alluded to something earlier, Andy, about it's almost like the algorithm or the metric of, can we get the global fleet of electric vehicles, whatever they are, 20, 30, 40 years hence, moving around more efficiently and easily, and certainly talking about these resource challenge, on having a ubiquitous, easy to use, relatively cheap charging infrastructure, rather than ever more bigger batteries. Do you know of any work that's modeled that to try and come up with a kind of modeling tool to say, yep, the ideal battery size is 30 kilowatts because this charging infrastructure? Is there anything that exists on that, Andy?
That was the logic behind the 24 kilowatt hour Leaf battery.
Okay.
That was a very too rational approach to the use of EV, not taking into account really people's range anxiety and what have you, or the need for that one long journey a year. But if you think through the Moore's curve, because we tend to look at things statically, don't we? We look at where we are today and project all the problems from now, like nickel. Yeah? You won't need that much nickel in the future. You'll have the feedstock coming from recycling. If you increase the energy density, which you inevitably will, you can get away with smaller batteries. And if you address the charging infrastructure, you can get through with yet yet smaller batteries. So there's just a few consequential actions to address the potential problem. Charging infrastructure is a big one of those. Charging infrastructure, look, I've tried twice in my career and failed twice in my career to introduce.
Third time lucky, Andy.
Well, you never know for swap. The problem of swap is that there is. I mean, we as an industry have never even been able to solve a common plug. So how the heck do we think that we're going to have a common battery? Because the size of the battery is fundamental to the way that the vehicle looks. It's fundamental to the way that you express the brand. It dictates where the wheels and the firewall go. Therefore, it dictates everything on the car. The idea that Better Place, who were, of course, the first to try.
Well, we both know Shire Gases quite
Indeed,
well,
the idea that the car makers were going to allow themselves to become the mobile phones of the car industry was just absurd. The idea that battery swapping in cars will work, in my opinion, absurd. Now, where it can work and seems to work is in scooters and motorbikes, where you can have a ubiquitous battery that might work in lots of different brands, and I think that's reasonably interesting. Likewise, we have got to move towards a common plug, and that can happen. I mean, Europe can legislate around a common plug and force as they do for even the radiuses on a car is legislated. So why the heck can't we legislate around a common plug? And I think that's the way that it has to go. But what you have to do, if you have to allow basically us to do our daily journeys in a carbon-free manner, and I think take away the anxiety of the technology.
What's coming out, though, that I'm very pleased about, it is the hope aspect, the think different aspect, the we will find solutions aspect, not just because it's, you know, a nice aspiration or whatever. All of you talking have knowledge and working experience of these things. So it's not just fingers crossed stuff, you know, it's predicated on knowledge, awareness of science and chemistry and all of these things. But can I come on to you, Achim? We're living in a world where, and I think Julia mentioned it before, most people really didn't pay attention to logistics, you know, supply chain. It was like, well, that happens, you know, that's fine. Then post-COVID and post all these things, and then the world wakes up, everybody suddenly is like, knows the phrase, you know, supply chain. I can't get my iPhone, I can't get my gadget, my electric vehicle is 15 months away. Why? Well, there are supply chain problems. Well, what does that mean? Where now can we go as we try to both come out of the post-COVID landscape, deal with the challenge in Europe at the moment, go on this shift to electrification, deal with climate change challenge, reduce the carbon footprint? Oh my God, you know, you're adding up all of these different things. How does a traditional industry like the logistics industry cope with all of that? And how can you be part of a new reinvented future? Well, I mean, what are you doing to help all of us, if I can put it like that? Sorry to put you on the spot.
That's fine.
And batteries, they're bloody great big dangerous things when they're charged up.
Correct.
It's full of this incredible energy. So how are you coping with all of this? I mean, Julia alluded to some of the specifics, but what can you tell us?
Well, the most expensive part of any electric vehicle is obviously the battery. So it's important for the OEM, for the tier 1 supplier, to manage the supply chain of the battery. And we heard from Julia before that shipping a new battery is difficult. Shipping cells is very difficult because of their nature, that they can spontaneously combust. There is a fire, explosion, planes came down, ships went on fire, we heard about cars exploding. So it is paramount that logistics companies have the capability to manage the inbound flow of new cells and new battery packs. And battery packs are bulky, they're heavy. They come in these sheer numbers, which is the most heaviest component which goes into a car. So previously there were 2,000 parts and components which we shipped into a car assembly plant. And now for EVs, we're talking 600 to 800 parts and components. But yet again, the most difficult part is to ship the bulky battery. And how logistics companies are helping us on this electrification journey is to ensure that we can actually transport these massive numbers of cells which need to be shipped all around the world. We alluded to it earlier during our discussion that it's underestimated how many batteries we need, and it's also underestimated how much capacity we actually need to ship those batteries. And right now, yes, we have gigafactories in Europe, but Europe is not yet self-sufficient for the supply. So we have to import from Asia. And there's not enough space, available to ship all these batteries in a timely manner into a car manufacturer plant or into a battery assembly plant where we are used in the automotive industry to just-in-time and just-in-sequence production. And now it's, maybe you're coming on Wednesday, but maybe you're coming 10 days later. Okay, we all heard about the supply chain incidents, which are happening every day all around the world. So the way how logistics can help is to work together in a vertical supply chain, to talk to port operators, to talk to carriers, and to provide capacity, first of all, to provide a channel to transport these batteries in an effective and in an efficient manner. And that being said, again, think about the quantities which are coming out of a gigafactory, and we're going to have 50 gigafactories in Europe sometime soon. How are we going to manage that? That's difficult.
You talk to some people, there's the ambition to have 50 gigafactories, but will they get the funding? Will they find the customers? All of that stuff. But can I ask you about innovation and progress? So you ship all over the world, finished goods, raw materials, all of this stuff. So can you help the American, particularly the American and the European industry, the new gigafactories, learn anything from what you observe elsewhere and put in some new technology or innovation to certainly reduce the carbon footprint, but also make them work really, really efficiently? What can you offer people other than saying, yeah, we'll move that thing from there to there? Can you be more, I suppose the word's consultative? Is that stuff you're beginning to do, perhaps?
Yeah, our industry, of course, also advanced over the last years. And COVID has been the hindrance, but also has been an accelerator with regards to identifying new technologies and advancing certain topics. We discussed, for example, earlier, why haven't we advanced further with buses for public transportation? Well, maybe because of COVID, because COVID hit in, we were on lockdown, nobody wanted to actually buy a new electric bus because people couldn't travel, but people were more interested in buying a smaller car to travel on their own, from A to B. Now, in logistics, what the industry is doing, the industry is first of all also decarbonizing supply chains. And you all heard about sustainable fuels which are available. Trucks can run on fuel from vegetable oil, for example. Ships run on biofuel, and aircrafts can run on so-called sustainable aviation fuels. And that is all helping to reduce the CO2 footprint, which we are producing when transporting cargo from A to B. So one, we are deploying renewable energies and sustainable energies in order to avoid fossil fuels. And B, what is probably also more important or equal important is to identify the right lanes and the right vessels and how can we avoid transport. So we spoke about Norway having so many battery factories, and we also have one battery recycling plant. That's awesome, because then we can avoid transportation. But today, transportation avoidance is very, very difficult, because in Europe we have, let's say, 5 or 6 recycling companies which have the capability to recycle battery packs. There's no recycling plant in Spain or in Portugal, for example. So how do we transport a battery pack from a car which has been involved in a traffic accident into end-of-life recycling into France or Germany? New battery transportation is complex. Well, if the battery is damaged and or defective, it's even more difficult to do that. It's open heart surgery. Legislation doesn't make things easier.
Can I ask you a question, a commercial question, I suppose, really, about electric vehicle is a disruptive proposition to the incumbent internal combustion engine industry. Far fewer moving parts, far smaller bill of materials, etc. Isn't this a bad thing for a company like a big logistics company, that so much less stuff is going to get moved around the world? Good for the world, But how does that reconcile with you in trying to, if you'd like, work with that and maybe encourage it even? Are you, you know, how does that work within the company in terms of strategy and, you know, the shareholders, etc.? Maybe an awkward question to ask, but I've asked it.
Well, let's speak for the industry. The industry is, of course, very much interested in also decarbonize all the supply chains. That's a given. And in particular, forwarders and large carriers, it's their responsibility, similar to production plants, okay, having to reduce their footprint, so do carriers and international freight forwarding companies. And of course, we at first sight, we do not like the reduced complexity of 2,000 parts and components in a warehouse to pick and pack for the aftermarket to deliver it to the dealers, and now we only have 600 parts. So at first sight, that may sound less attractive. Yet again, we see a mode shift. So the parts and components which are available, they are smaller, they are more fragile. They can go by air freight because they have a much higher cost. So we are replacing, so to say, cargo which went long distances by ship or by truck. Now you put them on the aircraft and you fly them from A to B. In addition to that, cargo handling needs to be different, of course. You know, cargo is much more sensitive than it was before. And maybe Tom, before I let you talk, in the past, the traditional supply chain for internal combustion engines, they were uber optimized. They were oiled. They were super efficient. They squeezed the lemon out of the supply chain. And that is not the case for EV startups. Why? Because the bill of material is new. They are new suppliers. These are new parts and components. So sometimes companies, they deliver too much material. They deliver not enough material. You're supposed to collect 50,000 pieces of a certain product tomorrow, but you only get to 25,000. So we need much more agility in the supply chain compared to the previously super oiled and well-efficient and effective supply chain.
Yeah, which is a perfect way of coming on to Christopher then. You talk to the auto industry, all sorts of people in the auto industry every day. This certainly, as Andy's alluded to, and certainly Daniel has, we are migrating from this very well-structured internal combustion engine machine, you know, by machine I mean manufacturing, supply chain, tier 1, tier 2, etc., to this much more simplified electric vehicle proposition, bill of materials far fewer. How is the industry dealing with this? It's like crossing a river. It's like, you know, what's the thing? Swapping horses midstream. It's in the middle of trying to do that. How is that all going to shake down, do you think? Or, you know, what are the stresses and strains that are emerging now in all of that?
Yeah, it's a good question. I think we can take them from a few different angles. I mean, one is to say, when I speak to car makers like Volkswagen, they immediately break the myth that it's easier to build EVs. It's like, I mean, yes, in principle, these modules and stuff, but as the rest of this conversation has alluded to, that supply chain is far, far more complex. So kind of right off the bat. And what we've seen over the last two and a half years of supply chain disruption is the OEM having to look further upstream. If we look aside from EV, the OEM needs to understand the semiconductor process broken down into 10 different stages so that they can even begin to understand the impacts that might be having over the next 1 to 4 months in terms of semiconductor supply. It will be the same, I think, or increasingly is the same in the battery supply chain. We already see companies going upstream, looking in mining, JVs in mining. Volkswagen and Mercedes were with Olaf Scholz in Canada signing agreements. So that this is not something that the OEMs themselves are going up there. And I think that will carry down into logistics. Of course, for that transition, coming back to the battery topic, you know, when you need to build a car that's 3.2 tons in a factory, well, lots of factories in Europe don't have the hangars and conveyors that can do it, right? So you need to spend $1 billion to convert that factory, to put in the infrastructure just to move that material. Usually you're doing that alongside keeping production. Okay, Volkswagen has done a couple of EV-only plants, but you know, many, as we know, BMW, for example, have plants which are producing, at least for the next generation or two, multiple lines. And then you don't have a less complex supply chain, then you have more parts going in. Your EV part might be fewer modules, but you're also building ICE alongside hybrid. And that, okay, it has an end date. Maybe it's 2035 for Europe, but actually Europe is export, so it's probably going to produce for. So managing that phase down in the supply chain is going to be pretty complex anyway. I think for some of the tier suppliers, the tier 1 suppliers, that's particularly an interesting challenge because they're kind of squeezed from a few different sides. Even again, outside of EV, a tier 1's trying to get the visibility of what's coming. From its OEM in terms of the connectivity to the production schedules and forecasts. Those, as you know, have been extremely unreliable over the past two and a half years. They get notified from one week to the next that there'll be shutdowns. That has huge implications for their operations. They don't have the scale that a GM or a Volkswagen has when it comes to getting parts and containers. They're trying to get 3-4 containers sometimes versus 1,000, so they're squeezed there. So that lack of, this is why they need the Kuehne+Nagels of the world, by the way. As the EV transition continues, where they fit into that space becomes another question too. I mean, are they going to be squeezed by battery cell suppliers, producing more of the modules, or OEMs insourcing more of that? So where does the tier 1, I'm being general here, of course, there are thousands of different kinds of tier 1s, but if we look at the powertrain, what role they'll have. That I think is interesting from a supply chain point of view because there's software aspects and systems aspects that they can take on in between that. That will have implications for how they manage that. So
now, observing all of that, the structural shift, the complexity, as you've described, of all of it, and a few others have commented on this, is it fair and reasonable for us to expect the industry to fund all this itself? From profits from their war chests or whatever you want to call it, or given the fundamental importance of the employment, the significance of the industrial base, particularly in countries like Germany and France, that actually this needs much more state-sponsored support in the same way that has happened in China. Because if we don't do that, we're tying our hands behind our backs. And we're now seeing perhaps the beginning of that emerging in America with the, Inflation Reduction Act, significant investment in saying, let's get real a bit now. Do you see that that's what we must see in Europe if we want the European auto industry to survive in any real fashion?
We talked earlier about unintended consequences, right? And I think IRA is a good example of lots of unintended consequences, not least for Europe, in terms of where they're meant to fit in the whole ally sourcing, friend sourcing approach that the US now wants to take. And by the way, this is maybe not initially answering your question, but just in the supply chain sense, the US approach now, which is initially, okay, you have to build it here or in North America, or potentially with friend sourcing or ally sourcing, not yet fully defined. This is common, frankly, you can't do it all in one place. You're going to need that multiple sourcing points, and if it's friend sourcing, we better define that pretty quickly to understand it. Otherwise, we're going to be in some trouble. I think for Europe to take that approach, it's probably a little outside of my expertise, but to try and balance between, EU regulations and rules on how subsidies work between national. But I think we do see that that mold getting broken. It seems like Germany's taking a more assertive approach, and probably the EU will have to go in that direction to compete. If the US continues that way, which I don't want to timestamp the recording too much, but we may see some interesting results today which disrupt the trajectory of the US legislative.
If I could add,
yeah,
I would say it's not about the funding, because if you watch in history, like Henry Ford didn't need funding, Elon Musk doesn't need funding. What they need is the government to make sure they regulate to ensure charging stations are available for the everyday person. So the Infrastructure Act, the pieces I can digest and read, it's about the Department of Energy's created a supply chain deployment person. There's these areas they're creating because, I think he spoke at the Automotive Logistics Conference, and he stood up there and said, I'm 2 weeks into the job. I have no idea where we're headed, but I'm here to take supply chain into that conversation to make sure the money is sent where it needs to from the government, not around the entrepreneur and the OEM, but around the things we all need to happen that we're not thinking about, if that makes sense.
It does, but can I put it to you that if in our recent times, we came to the rescue of the banking industry, both, well, in the Western world, to protect the banks and injected billions to maintain that equation. We then had a global pandemic, and again, we injected hundreds of billions into the system to maintain individuals' lifestyles and keep the world working. Why can't we then inject a similar amount of money to maintain the industrial base that relates to one of the most significant parts of Western economies, which is the auto industry and energy? Surely we've set a precedent for it. And to just not do that, and fingers crossed, let's hope we can compete, let's all the rest of it, when clearly China has had a state-sponsored ambition, and it's not an anti-China, pro-Europe, pro-anything, it's pro-economic and geopolitical balance, which more than at any other time right now in Europe, we know that's a pretty important thing to have. So to walk into a world where we're not going to have that seems illogical to me. Henry?
Yeah, Roger, so what I think is important in the US now, both parties are pretty uniform on China. And that's very important because a lot of the Inflation Reduction Act is about cutting China out of these supply chains. And if the US, as it has, frames it in terms of jobs and combating China, we could see a more cohesive approach. The issue with Europe is we've seen this recent visit by Germany to Beijing, is there's not a unified view on China. And I think in the US, it's an example of geopolitical competition bringing out good results, right? In some ways, it's actually quite helpful to get both Republicans and Democrats together to think we are challenging China. So that's an interesting way of looking at it.
Yeah. Andy, you are a great champion of progressing ourselves to full electrification, realizing the ambition of renewable energy by having that ubiquitous storage, etc. Give us a flavor, please, if you can, of hope in how not just Europe, but the world collectively goes on that journey to a successful outcome.
The world has no choice. I mean, we're in a climate crisis, and it's a crisis that isn't a problem for our grandchildren or our children. It's going to affect us, right, living today. It's around the corner. So I have to believe in humanity's ability to react to a crisis. COVID as an example, and the rise of the vaccine. And I think as it becomes more and more apparent that climate change is affecting you become more and more invested in finding solutions. Engineers find solutions. That's what we do. Okay, and it's then, I think, up to governments to decide whether they want to invest in that intellectual property, whether they want to invest in that industry, or they want to fake Adam Smithism, if that's a word. I mean, the idea that you live in a capitalist society, and therefore, as has been the British mantra for a long time, that you have this laissez-faire approach to industry, let industry regulate itself. That in the context of world business is utter nonsense. Yeah. The Chinese finance their business, the Americans finance their business. Even the EU sets 70% of batteries have to be made in Europe, so it has a protective barrier around it. So I think on two levels, the level that humanity will react to the climate crisis eventually, probably too late, but we have innovative populations that will address it. I'm very confident that mankind will address the climate crisis when it sees it every day. Whether we end up with an industrial footprint in the same place that we've had it historically, I very much doubt. And I'm very pessimistic about how strong vehicle manufacturing in the UK will be unless we wake up very, very, very quickly.
Within the next months and year or two.
We have, have one battery factory in the United Kingdom, and we talked about, how many we need around Europe itself and the overall capacity that we need, and we don't have a game plan.
Yeah.
So unless you wake up to that fact, then you're going to say goodbye to 800,000 direct jobs in the car industry.
Yeah, that's not a nice thought. So we definitely need to try and avoid that. Tom, can I ask you a kind of sort of wrapping up question, final question? Norway is a relatively small country in terms of certainly population, but significantly blessed both with old energy and now new energy, and deriving huge wealth from that. As a Norwegian, can I ask you, do you feel any kind of moral imperative to have a leadership position in this in terms of some of these significant funds that need, investing, that need developing of all of this? What's your sense, if you like, as a Norwegian citizen and a global citizen, what your country could do next?
Well, if I'm going to try to end on an optimistic note.
That's good.
So 1 week from today, it's argued that the world passes 8 billion people. Norwegians are about 5.8 million, right? We are probably the most endowed and blessed sort of nation on the planet in terms of natural resources. Do we have a profound responsibility to make use of that to sort of improve the state of the planet? Absolutely. I mean, we export 95% of everything we produce. Europe fundamentally depends upon the energy produced in Norway. Norway fundamentally depends upon being able to sell our products to the world. It's a moral imperative for us to sort of show that we can do better. And the super profit that we're raking in right now should, in some way, shape, or form, to a larger extent than what it is now, be allocated to the energy transition and to build up energy resilience in Europe, for sure. Is it going to happen fast enough? Most likely not, because our political processes are just, slow. But maybe I just sort of summarize by saying this. At the end of the day, electrification of the planet is happening. It is going to happen. It's inevitable. We need to triple electricity production, roughly speaking. That electricity production needs to come from renewable. The two main sources of that is solar and wind. We need to 20-fold the production of solar and wind on the planet. And to store that solar and wind energy, we need to more than 200-fold the amount of storage devices we have. It can be 2,000 times, but humanity and engineers are going to optimize that so that we find ways to limit how much batteries we actually end up producing. All of that will create new constellations, new companies, existing incumbents and large companies will be disrupted. There will be new sort of value chains that will be established. The logistics companies will team up with the recycling companies, and you will see, recycling facilities on board logistics, freight carriers, etc. At the end of the day, this is about renewable energy and how we transport the sun ray and the wind to its ultimate use. And think about it, renewable energy, feedstock is free. Feedstock is free. It doesn't cost anything. Yeah. And Moore's law indicates that, or the equivalent of Moore's law in industry, every time you double capacity of something, the cost drops by something. And we need to double that something many, many times, which means that the cost of energy at some point will be dramatically lower than what it is today. What do we do then?
Tom, that's fantastic. You've given us some lovely metrics there, that kind of equation of where we need to get to the future. And actually, coincidentally, maybe not, that echoes exactly what the most recent International Energy Agency World Energy Outlook confirmed, when it said we are running the world so much more on electricity, so of course we need to make sure that's not being produced from coal, not being produced from gas, that as much as possible it comes from that energy that arrives here 9 minutes after it was made on the sun to the earth, a lot quicker than the fossil fuel energy, which is ancient solar, takes to come out as oil or gas. So, there's a profound logic to this in terms of the fundamentals of what the world and the planets and whatever we see ourselves as the Earth are blessed with, that we should just go to that very fundamental and basic thing of, the sun, particularly the sun, creates everything and anything that's ever existed on our planet. So that has to be the default option for how the world works. And I think you put it incredibly succinctly and very nicely. So, Tom, thank you very much. Thank you, everybody, for, I think, a very interesting kind of sewn together narrative around, what do we need to do, reality checks, but hopeful threads of these are some of the numbers and metrics of what we need to do. We wrestle with the fact that I think in a democratic world, we do have these schisms of 1 minute it's on, then it's off, as opposed to more command and control arenas, countries, where they have a much more long-term connected philosophy. That's the reality of what it is. So we just deal with that. But I think rising to the occasion and I think Andy's point particularly, and I've very much come to this late, that engineering and engineers are like artists. They are creative people. Here we are at the RSA that celebrates a lot of that. But engineering a future world where it's sustainable and fair and equitable and democratized in all the right ways of democratizing, democratizing opportunity, is exactly where we can go. And I think you've all given some really good examples of how that can happen. So thank you. I've really enjoyed this conversation, a huge amount. Thank you so much.
Thank you.
Thank you.